Lesson 1 Measurement in Science and Technology. Important questions and their answers. Very short answer type questions. Q. 1. What is the value of a physical quantity? Ans. The value of a physical quantity is the product of a numerical quantity and a unit. Value of physical quantity equals numerical quantity x unit. Q. 2. What was fathom? Ans. Fathom meant the distance between the ends of the hands of an Anglo-Saxon farmer when his arms were fully outstretched. Q. 3. Who used the unit pace? Ans. Romans used the unit pace. Q. 4. Mention the ratio of bricks during the Mohenjo-daro era. Ans. 4, 2, 1. Length, breadth, width. Q. 5. Mention the unit used to measure distance during the Chandragupta Maurya period. Ans. Yojan. Q. 6. Who wrote Ain-i Akbari? Ans. Abul Fazl. Q. 7. Mention the essential units of mass that were used during the British period. Ans. Reti, Masher, Toller, Shatank, Sear and Mound. Q. 8. What is physical quantity? Ans. Any quantity which can be measured is called a physical quantity. Q. 9. What is mass? Ans. The mass of a body is the amount of matter contained in the body. Q. 10. What is a mole? Ans. A mole is the amount of any substance equal to its molecular mass expressed in grams. Short answer type questions. Q. 1. Define mole and candela. Ans. Mole is the SI unit of amount of substance. It is defined as the amount of any substance which contains as many as elementary units, as there are atoms in exactly 0.012 kilograms of C12. Candela. The candela is the SI unit of luminous intensity. It is defined as the P luminous intensity in a given direction of a source that units monochromatic radiation of frequency 540 by 1012 Hz and that has a radiant intensity of 1/683rd watt per steradian in that direction. Q. 2. Find out the derived unit for force. Ans. Force equals mass x, acceleration equals mass x, change in velocity time. Since change in velocity equals length time, so force equals mass x length time x. 1 time equals mass x length time squared. The SI unit of force can be found by substituting the SI units of the base physical quantities on the right side of the expression. Thus, SI unit of force equals kilogram meter per square second equals kilogram ms2 squared. Q. 3. Explain the following terms. A. Digit. C. Handspan. A. Cubit. B. Foot. D. Fathom. Ans. A. Digit. It is the width of a single finger. B. Foot. It is the length of a foot. C. Handspan. It is the distance between the tip of the thumb and the tip of the little finger when the hand is fully stretched. D. Fathom. It is the distance between the ends of the hands of an Anglo-Saxon farmer when his arms were fully outstretched. A. Cubit. It is the length of an arm. Q. 4. What were the limitations found in the ancient units of measurement? Ans. The ancient units of measurements were not standard units. They mostly involved body parts for the measurements which varied from person to person and hence not fixed. They didn't have qualities of a standard units. Ancient units were inaccurate, arbitrary and were not reliable as they were not well defined. Q. 5. Briefly explain electric current. Ans. Electric current. The SI unit of electric current is the ampere. A. 1 ampere is defined as the magnitude of current that when flowing through two long parallel wires, each of length equal to 1 meter, separated by 1 meter in free space, results in a force of 2x 10 to 7n between the two wires. Q. 6. What is mass? Explain. Ans. Mass. The SI unit of mass is kilogram. 1 kilogram is the mass of a particular cylinder made of platinum iridium alloy, kept at the International Bureau of Weights and Measures in France. This standard was established in 1887 and there has been no change because this is an unusually stable alloy. Prototype kilograms have been made out of this alloy and distributed to member states. The national prototype of India is the kilogram number 57. This is preserved at the National Physical Laboratory, New Delhi. Long answer type questions. Q. 1. How do we use SI prefixes? Give examples. Ans. In order to use SI prefixes, we have to keep a basic rule in mind. The rule is that the prefix is chosen in such a way that the resulting value of the physical quantity has a value between 0.1 and 1000. Let us illustrate it with examples. Radius of Sun 6.96 by 10 meters equals 696 by 106 meters. 696 megameters, 696 megameter. Alternatively equals 6.96 by 108 meters. Equals 0.696 x 10 m. Equals 0.696 gigameters, 0.696 gigameter. Q. 2. Describe rules for representing SI units. Ans. The most commonly used rules are as follows. I. While writing the value of physical quantity, the number and the unit are separated by a space. For example, 100 milligrams is correct but not 100 milligrams. E. No space is given between number and degree. C. Degree, minute and second of plane angle. E. The symbols of the units are not changed while writing them in plural, e.g. 10 mg is correct but not 10 mgs. IV. The symbols of the units are not followed by a full stop except at the end of a sentence, e.g. 10 milligrams of a compound is incorrect. V. In writing the SI unit obtained is a combination of units, a space is given between the symbols. Thus ms represents meter second while ms stands for millisecond. That is, if the units are written without leaving any space, the first letter may be taken as a prefix. Y. For numbers less than unity, 0 must be inserted to the left of the decimal point, e.g. writing 0.928 grams is correct but not 928 grams. 30.5 joules or 30.5 J is not correct. V. When using powers with a unit name, the modifier squared or cubed is used after the unit name, e.g. second squared, gram cubed etc. Area and volume are exception. In such cases the qualifier for the power comes first, e.g. square kilometer or cubic centimeter etc. V. For representing unit symbols with negative exponent, the use of the solidus sign should be avoided. If used, no more than one solidus should be used, e.g. the unit for gas constant, jkmol, may be represented as jkmol but not as jk per mole. Q. 3. How did our ancestors make measurements? Explain. Ans. The recorded history shows ample evidence that the different parts of the human body were used as a point of reference while making measurements. Some of these were digit, the width of a single finger. Foot, the length of a foot. Cubit, length of an arm. Hand span, the distance between the tip of the thumb and the tip of the little finger when the hand is fully stretched out. Similarly, fathom meant the distance between the ends of the hands of an Anglo-Saxon farmer when his arms were fully outstretched. It is interesting to note that these are still used sometimes. Certain historical units were based on the things around us, e.g., Romans used a unit called pace which was equal to the stride of their army contingent, and they called the distance traveled by it in 1000 paces to be equal to a mile. Similarly, the grain was used as the unit of mass in 16th century and was equal to the weight of a wheat grain. Q. 4. Describe the need for a standard unit. Ans. The units based on parts of human body are arbitrary and inaccurate. The results of the measurements vary from person to person because size of the unit is different for different person. For example, the units like a cubit or a foot would depend on the person making measurement. This created problems in trade between different countries and obviously in the day-to-day transactions. अध्याय यहाँ पर समाप्त होता है। आप स्टडी कर रहे थे ओपन स्कूल की डिजिटल ऑडियो बुक्स से ऐसे ही और अध्याय पढ़ने के लिए और NIOS की और वीडियो पाने के लिए हमारे चैनल को सब्सक्राइब करें। वीडियो पसंद आने पर लाइक करें। अगर आप कुछ पूछना चाहते हैं तो हमें कमेंट करें और लेटेस्ट अपडेट के लिए बेल आइकॉन को दबाएं।